Hi, my name is Buja, and I'm going to be presenting the first part of our presentation. We're going to be talking about the manufacturing process of the bicycle. First of all, the bicycle is a two-wheel steerable machine that is pedaled by the rider's feet. Basically, standard bicycle has the wheels are mounted in a mantle frame with the front wheel held in a rotatable fork. The rider sits on a saddle and steers by leaning and turning handlebars. This is a diagram of the parts. We're going to be talking about them one by one. First of all, the frame consists of top-down seat tubes and the seat. It provides essential structural strength and creates the skeleton. The frame needs to support itself and other components alongside handling the cyclist's weight. Most common design for the frame is called diamond or double triangle. The shape allows the vehicle to be as light as possible while not compromising the strength. The most common materials used for your frames are aluminum alloys, carbon fibers, steel, and titanium. We're going to be starting with steel frames. Steel frames are good for comfort, durability, repairability, and affordability, but they're also heavier than most alternatives and not corrosion resistant. The production stages are tube preparation. Tubes may be seamless or seam. Seamless tubes are constructed from solid blocks of steel and drawn into tubes from solid steel billets. On the other hand, seam tubes are made by drawing using flat strip stock, wrapping it into a tube and welding it together. In order to increase their strength and decrease their weight, seamless tubes may be further shaped by butting. Butting is done by increasing the thickness of the ends of the tube where most stress is and thinning the walls at the center of the tube where there is relatively little stress. Another process is tube tapering, which reduces the diameter of one or both ends of a tube. It's done by compressing or stretching the metal using dies. The next stage is tube shaping. There are different ways. For instance, mithering means the ends of tubes are precisely cut with specialized machinery to create angles or joining. Bending and forming is done by machinery to create specific shapes. Frame assembly, there are some processes used to assemble the structure. Construction with lugs, which are cast for machine steel sleeves, are fitted over tube ends. Tubes are brazed into lugs using brass or silver filler material, creating joints. TIG welding is another procedure used. Tubes are aligned in jigs that ensure correct geometry. Field brazing is another option, which is similar to lug, but instead of sleeves, a fillet of brass is applied to form joints. Finishing touches, final frame undergoes alignment checks. Chemical bathing prepares the steel for paint. Another way is for excess flux and brazing metals to be cleaned off by pickling in acid solutions. The next type of frame is aluminum frames. They are lightweight, affordable, corrosion resistant, and easy to access, but are harder to ride and prone to fatigue and difficult to repair. To construct the frame, we use tube butting and hydroforming. Hydroforming is a specialized type of die forming that uses high pressure fluid to press room temperature working material into a die. The stages are raw material sourcing and alloying. Aluminum ingots is an option in which the process starts with large ingots of raw aluminum. On the other hand, alloying elements are added. Tube formation consists of extrusion, butting, and hydroforming. In extrusion, cylindrical billets are heated and forced through a die under immense pressure, creating long tubes. This involves either mechanically thinning the tube center or swagging the ends to increase wall thickness where it joins other tubes. The next stage is tube preparation. Cutting and mithering are used to cut tubes into precise lengths and angles using specialized saws or CNC machines. In frame assembly, to assemble, we use jigging, in which tubes are carefully placed in a precise jig to ensure alignment. Tack welding, which describes small welds temporarily holding the tubes in position, and welding. Mostly TIG welding is used. Post-welding includes the frame being heated at a temperature for a period of time to precipitate the strengthening phases. After heat treatment, alignment check is done to ensure it meets tolerances. And in finishing stage, sanding and smoothing stage, welds are sanded and smoothed for a clean appearance and to remove any stress risers. Then the frame receives either a durable paint coating in various colors or an anodized finish for a corrosion resistant and often colorful surface, which is called anodizing. Finally, manufacturer branding and model decals are applied. Carbon fiber frames are light, strong, vibration absorbent, but they carry unseen internal damage. The stages are design, CAD, and FEA are used. In preparation, carbon fiber fabrics are impregnated with epoxy resin. It's essential for transferring load between fibers. Then the sheets are cut into patterns. In molding and layup, there are two main types of molds. When using monarch molds, large complex molds determine the entire frame shape. Internal bladders can be used for pressure. With tube-to-tube molds, individual tube sections have their own molds. For layup, which is after molding, technicians place each prepreg layer within the mold, ensuring alignments. In curing, molds are placed in ovens or autoclaves to activate the resin, and in finishing, the cured frame is carefully removed from the mold, which is called demolding. Excess material is sanded away, and the frame undergoes quality checks. Areas for attaching components are drilled or integrated during this. The saddle refers to the part of the bicycle where the person sits on. It consists of the saddle and the seat post. The seat is covered padding. Most manufacturers prefer closed shell foam for this. Here's a breakdown of the manufacturing. Plastic shell. Shell forms the main skeleton of the bicycle seat. The contour of the saddle is rendered in a metal mold. Then seats are injection molded. Injection molding is a process for producing parts by injection molten material into a mold. The resin solidifies in the mold is unclamped, and the plastic shell is forced out of the mold using some sort of ejector. For padding, the padding is a densely packed closed cell foam that provides comfort for the rider. The foam is cut along the contours of the shell and moves down and around the edges of the shell. The foam is attached to the plastic shell using spray adhesive applied using an air compressor or a spray gun. And the last part is the cover. The cover is cut out by hand using heavy held scissors. The top sheet is now affixed to the foam covered base. This process entails wrapping the cover down over the seat around the sides and sticking it to the bottom of the seat. This top sheet is carefully attached by hand using spray adhesive again. After the top sheet is attached to the base, it's stapled. Many bicycle seats are designed with a hollow metal rod that allows them to be mounted onto a bike frame. If a rod is included, it must be cut, shaped, and secured to the seat. These rods are heated and cut into smaller pieces with a heavy-duty saw, then shaped into the required form. Once shaped, the rods are placed into a tumbler with smooth rocks inside a rotating drum. Thanks for listening to me. The next part will be presented by my friend.
Hi, my name is Azra. Today I'm going to be talking about bicycle parts and their manufacturing processes. So the first part of the bicycle is the wheel. A bicycle wheel components include the rim, hub, spoke, tire, valve, and nipple. First, the wheel design is drawn in a computer program. Once a design has been established, a CNC rim is cut off a block of aluminum. Spoke holes are then drilled to the mount to the rim to a hub with spokes. Once the initial prototype has been built to what the final product will be, the designs are sent to the factory in where a number of prototype wheel sets are made. These wheel sets first go through testing by the factory. Once the rim is fully ready to be built, the factory can begin producing high numbers of the rims. The rims. The rim is the most obvious part of a bicycle wheel. They are typically made of alloy or carbon fiber. Rims come in all shapes and sizes. So the first type of rim is carbon rims. Each layer of carbon is laid by in a metal cast in the shape of the rim around the bladder that will form the inside of the rim. Once the rim is fully laid with layers of carbon in the metal cast, it is placed in the press to hold the mold in the place. Once the set rim is removed from the press and bladder is deflated and removed through the valve hole. After the rims are hard and set, the spoke holes are drilled, followed by decaling and clear coating. The first type of rim is aluminum rims. Aluminum rims are much simpler than carbon rims, thus they are lower cost. The aluminum comes in blocks and is pressed through a pre-made die shaped into the cross-section of the rim. This results in a long straight piece of rim, which is cut to the length and then bent into a perfect circle. The rim is placed into an automatic computerized welding machine that welds the same of that can be seen. After the rim is in a solid hoop, that braking surface is then attached into the rim with a cutting tool. The rims are then painted and clear coated as needed. The hubs. The hub is a central part of the bicycle wheel, connects spokes and joint wheels to the frame. Number of engagement points varies by hub determines how quickly pedal force moves the bike. Parts of the hubs. The first one is axle, rode through the hub that spins. The second one is bearings, small beads and enabling smooth rotation. The third one is hub shell, outer casting holding the parts. There are two types of hubs. The first one is front hubs, has a spindle, two bearings and an axle connecting the fork. The second one is rear hub, more complex, includes gear support and freewheel mechanism, allowing backward pedaling without the chain movement. So the manufacturing processes of hubs So the first step is prepare dry carbon fiber fabric pre-woven tubular layers. The second one is wrap fabric around an inner tube. The third one is placed in upper and lower molds. The third one is inject adhesive. The fifth one is apply heat and pressure to the form. Invention field. This process is for producing durable, lightweight bicycle hubs efficiently. Conventional method. Hubs are usually machined from aluminum or steel. For lighter designs, carbon fiber is used formed by layering, bonding with resin, and molding into the shape. So the manufacturing processes of the hubs. So the first one is covering. Tubular dry carbon fiber fabric is wrapped around the metal inner tube. The second one is molding. Inner tube and fabric placed in upper and lower molds and vacuumized. The third one is adhesive injection. Adhesive is injected into the molds. The fourth one is forming, heated and pressurized to impregnate and shape the carbon fiber layer. The fifth one is each carbon fiber layer is pre-woven, seamless, and has a closed curved cross section. The sixth one is assembling. The bearing brackets are mounted at the both ends of the tubular carbon fiber layer. Spokes. So there are three types of the spokes are rods that connect the hub to the rim. They transmit the power generated by pedaling and serve to keep the rims around the true. Bottle and bladed spokes are by far the most common. The material choice for spokes is stainless steel. Stainless is strong and will not rust. So there are three types of spokes. The first one is aluminum spokes. The second one is brass bike spokes. The third one is stainless bike spokes. Manufacturing processes of spokes. First of all, the wire needs to be unrolled and straightened from its packets. The wire is fed through three sets of rollers to untwist and is then cut, forming a spoke blank. It's then ready for the next processing steps. Swagging is the process of cold forging the spokes to reduce the diameter. When they are ready, they are fed into the spoke forming machine. First, the spoke blank is cut to the exact length. The head is formed by punch and the DT spoke is embossed. Finally, the threads are rolled. As with the butt spokes, this rolls in chains in the microstructure of the metal, increasing its strength. Bladed spokes go through one final step, called flat forging. The spokes are fed into a press and force up to 250 tons forms the bladed profile between two dies. So, tires have different types of weight and flexibility for each. However, each of them is made with the same components, which are sidewalls, body, tire bed, thread, and anti-puncture insert. So the manufacturing process of tires. Step 1 is preparing the compound for the production of the rubber. The second manufacturing process is winding the rubber onto rolls. The third manufacturing process is manual processing. The fourth manufacturing process is creating the thread. Wells. A well is a device that regulates, directs, or controls the flow of fluid by opening, closing, or partially obstructing various passageways. Types of materials used for manufacturing wells. The first one is cast iron, the second one is ductile cast iron, the third one is stainless steel, the fourth one is bronze, the fifth one is brass, the sixth one is cast iron lining, the seventh one is cast steel. Manufacturing process of wells. The first cycle is preparation of molten metal in the melting point, making of course, preparation of molding sand, making molds, pouring and casting shakeout. The fifth one is quality control. The second cycle, the first process is heat treatment or anneal. The second process is finishing of casting. The third process is quality control. And the fourth process is product meets the requirement. The third cycle is the first manufacturing process, preparation of castings before galvanizing, plating. The second process is plating, galvanizing of castings. The fourth cycle is the first manufacturing process is mechanical treatment of. The second process is assembling. The third process is quality control. The fourth process is product meets the requirement. The fifth and the last cycle is the first manufacturing process is leak testing on components. And the second process is fitment of final collectors of accessories. Nipples. Bicycle nipples are small, typically cylindrical components that connect spokes of the wheel to the rim. Spoke nipples are critical to maintaining the wheel's straightness and tension balance. So there are three materials of nipples: brass nipples, aluminum nipples, and stainless steel nipples. Manufacturing process of the nipples. The first process is automatic nipple machines finishes machine nipple blanks. The blanks are automatically fed into the machine out of a collecting bin. The second process is cold heating. The initial form is created by shaping the material in molds. The third process is the hole opening and surface process. Center hole, side hole, and channel opening processes are performed. The fourth process is threading. Internal screw thread is opened. The fifth process is growing. Channels are opened on the side of the nippler to allow the wire to fit more firmly. The sixth process is coating and finishing process. Corrosion resistance is increased with the nickel or chrome plating process. Rear brakes. They are made of aluminum alloy, steel rubber, or iron for strength and durability. So the first process of rear brakes is the mixing process. All components are mixed homogeneously. A central shaft rotates materials in a figure-8 notation with two blender blades homogenize them. The second process is hot pressing. This step binds components by applying pressure, reducing volume and heat. The press acts in cycles, allowing gases to escape. Sport bond friction material due to resin on the sport plate ensures adhesion. The second one's holes in the brackets allow resin flow for full fixation. Gear. Gear converts your effort at the pedals into rotating the rear wheel. Gears enable us to ride faster, climb steep hills with less effort. Gears can be made with a variety of metals including steel, brass, cast iron, aluminum, plastic, bronze, powdered materials. There are four types of bicycle gears: single speed, fixed gears, hub gears, derailleur gears. Manufacturing process of gears. So the first process is casting. This process involves pouring molten metal into a mold with the desired gear shape. The second process is forging. This process uses heat treatment and application of pressure to shape the blanks. Forging is ideal for producing strong and durable gears. The third process is blanking. It's a simple process where cutting tools are used to produce gear blanks. The fourth process is gear machining. Gear machining, a general term, encompasses multiple techniques. CNC machining is commonly used. The fifth one is hobbing. Gear hobbing is a technique for spur and helical gears. The sixth one is shaping. They're shafted into external gears. The seventh one is broaching. A broach is a cutting tool with teeth. The eighth one is milling. The use of rotating cutters is a prevalent practice in milling. Freewheel. Freewheels are machine elements with these characteristics. In one direction of rotation, there is no contact between the inner and outer ring. So there are four types of materials used for freewheel producing: steel, aluminum, titanium, and carbon fiber. Types of freewheels: ratchet and pawl freewheel, star ratchet freewheel, roller freewheel, spread clutch freewheel. Manufacturing process of freewheel. The first process is hot forging. This process involves shaping the raw material through intense heat. The second process is deburring. After hot forging, the crank's arms undergo deburring. The third process is sandblasting. To improve the surface finish, sandblasting is applied to achieve a matte finish. The fourth process is anodizing. This process involves creating a protective oxide. The fifth process is mechanical machining, the final step in the manufacturing process to create threaded holes for assembly. So this was my part. Thank you for listening.
Hi, my name is Nayat. I'm going to start with handlebars. One of the most important components of bicycles are handlebars. It allows the rider to balance and control direction of bicycle. Handlebars, also known as bike bars and drop bars, are curved bars on a bicycle that are used to steer the bike and control its speed. So we have handlebars type. It can be made from aluminum alloys, carbon fiber, steel, and titanium. Aluminum steel handlebars manufacturing processes. They choose aluminum or steel, and then metal tubes are made in long cylindrical forms and cut to the required length. Butting is a process to varying the thickness of the tube walls, thicker at the ends for strength and thinner in the center to reduce the weight. This method uses mechanical drawing or hydroforming methods, and then tubes are bent into shape using CNC Mandrel tube benders. Mandrels are inserted to maintain the internal shape during bending and avoiding crimping, and according to the handlebars shape, different bending types used. Mostly aluminum is heat treated to improve hardness, fatigue resistance, and mechanical properties. TAG welding is used to join crossbars and main tubes, and then welds are smoothed out by grinding or polishing. And for the surface finishing, anodizing method is used for aluminum materials, and powder coating or liquid painting method used to both aluminum and steels. So for carbon fiber handlebars, it is the same as steel and aluminum handlebars. For the finishing processes, it differs. For the finishing, all processes are sanded and cleaned, and clear coat or paint may be applied for UV protection. So we're going to continue with handlebar stem. The stem is component on a bicycle that connects the handlebars to steerer tube of the bicycle fork. Sometimes it is also called gooseneck. Stem has two types, threadless and quill. It depends on the bicycle type. Quill stem are used to conjunction with the threaded steer tubes, and quill stems important for adjustment of handlebars height, and threadless stem offer a simpler way, swap, flip, mix and match stem. Here are the photos. For the handlebar stem types, there are steel, titanium, carbon fiber, and aluminum alloy wrapped in carbon fiber. For the manufacturing process, steel stem are mostly made from chromoly steel or high tensile steel, and their properties are strength and durability. Firstly, steel tubes are cut to the required length. Tubes are bent and formed into the stem shape using CNC benders or hydraulic presses. The stem is welded at key junction using TAG welding or MAG welding. Chromoly steel requires careful welding to avoid compromising its strength. After welding, stem is sanded, polished, brushed as handlebars. For aluminum stems are lightweight, and commonly used for bicycle stem production. Aluminum alloys are selected based on strength and weight. The aluminum is extruded into tubes or bars and cut to the necessary length. CNC machining is also used here too. Forging is a method to increase strength, and also it uses heat pressure to shape the material. Hydroforming or molding can be used to achieve more complex shapes. Titanium stem. Titanium stem has a very good properties, strength, durability, lightweight. Because of hardness and reactivity, stem production is more challenging than the other elements. Titanium is shaped using CNC machining or hydroforming to create the desired stem shape. Mandrel bending or pressing is used to smooth, and TAG welding is also here used. After welding, the stem undergoes sandblasting, polishing, brushing as the others. For the front wheel brake, the front wheel brake is reduce the speed of bicycle or stopping, for it can be used for slowing down when cornering or steep downhill. It has critical role braking performance and control. There are 4 types of front wheel brake: rim brakes, disc brakes, and that has 2 types of it: mechanical or hydraulic. For front wheel brake parts, brake there has 4 types: brake levers, brake arms, brake pads, and rotors. For the manufacturing processes, front wheel brake has also a very similar manufacturing process as steam and handlebar. To summarize all the processes, firstly we start as usual CNC machining and then casting or forging. Then we need to stamp the brake pads in molded rubber or sinterated metal or resin. And finally, hydraulic system used: tubing extrusion and revisor injection molding. So head tube. Head tube is a central component in the frame of bicycle that connects the fork to the frame and allows the front wheel to rotate. The head tube also houses the headless bearing, which is responsible for smooth rotation of the front wheel and steering movements. For the manufacturing processes, it depends on the material: steel, aluminum, or it can be also carbon fibers. Once the material is ready, the tube designed for the head tube is cut to the required length and shaped either machining or hydroforming. To ensure it has the correct diameter, it headless bearing. The head tube is then integrated into frame. Steel, aluminum, and titanium tubes are usually, and also here TAG welding machine is used, and then CNC equipment used. And for the final thing, surface finishing is applied. Metal head tubes may be powdered coated and anodized as usual. So bicycle fork is a critical component that connects the front wheel to the frame and allowing for steering and load bearing. For the manufacturing processes, to summarize all the steps, firstly, steel tubes, commonly chromely steel or high tensile steel, are cut to the required lengths. The steel tubes are bent to form the fork legs and steer tube. This is typically done using mandrel bender or hydraulic press. The fork legs and steer tubes are welded: TAG welding, MIG welding, and then fork is cleaned, smooth, and finished. The pedal is the part of the bicycle that the rider pushes their foot to propel to bike forward. It transfers power from the rider to the drivetrain with the crankset. For the manufacturing of the pedal, pedal mainly has 4 parts: pedal buoy, axle, bearing, clips. And for aluminum or steel parts, forging or CNC machining is used. Axle is also used CNC machining and heat treatment, and bearings precision grading and assembly. And for the other materials, manufacturing processes are similar as steel pedal manufacturing. The crankset converts the rider's pedals force into rotational motion to drive the chain and near wheel. It consists of crank arm, chairwing, spindle, and bottom braked axle. For the manufacturing processes, to summarize it, firstly it starts with forging, and then as usual CNC machining and carbon fiber layup, and then heat treatment, and for the finishing, painting.
Hi, I am Izan and will continue with the derails. In essence, the derail allows riders to adjust the pedaling effort. It lets us accelerate quickly on flat surface or reduce pedaling effort on uphill slopes by shifting the chain across multiple gears, which alters the wheel's speed, and power distribution. The Delirial significantly improves long-distance or off-road rides, as its ability to shift gears smoothly. Essentially, a Delirial is a variable ratio gearing system that consists of a chain multiple differently sized spokes. Bicycle Delirials are categorized on their position and control mechanism. First, front Delirials, and second, rear Delirials. Cable pull describes direction in which cable approaches and activates the Delirial. This is determined by design of bike frame and how cable is rotated to reach Delirial. Top pull Delirials receive cable from above. If cable runs along top tubes and then descends to the front Delirials, it's classified as a top pull setup. Cage types. Double cages are designed for cranksets with two chain rings from a side view. Both the inner and outer plates of the Delirial cage have similar shapes and profiles. Triple cages are made for cranksets with three chain rings or for setups with two rings that have a large size difference. Swing types. Bottom swing Delirials have cage attached to lower part of the four-bar linkage. This is the most commonly used Delirial design. Top swing Delirials, on the other hand, attach cage to upper part of linkage. Clamp traditionally front Delirials are attached to bike frame using a clamp that wraps around seat top. Brace-on instead of clamping brace-on, front Delirials bolt directly to small tab on bike frame seat top. This eliminates need to match clamp size but requires a compatible frame. E-type front Delirials attach via plate positions beneath the right side, bottom bracket, cup plus, and an additional bolt threaded into a mount on seat top. DMD. Developed by Specialized DMD Delirials, bolt directly to mounting points on the chainstay. This setup is designed for full suspension mountain bikes, where movement to suspension affects chain alignment. Delirial setup. There are four components of proper front Delirial setup. Delirial hike. Shimano Ultegra Delirial comes with a convenient sticker that indicates correct height specification. The sticker is meant to assist during the initial installation and should be removed afterward. Delirial angle. For most Delirials, the outer side of cage should be aligned parallel to chain rings for optimal performance. The key consideration is modifying height and angle at the same time. Cable tension and mixed rim. These adjustments considered together because they influence one another. This is particularly important when building a from scratch. Real Delirials. The real Delirial serves two primary purposes. It shifts chain across real spokes and maintains purple chain tension when switched to smaller real cogs or front chain rings. Despite design differences, most real Delirials are similar. They include a cage that holds two pulleys, which quiets chain in a S-curve. These pulleys are called the quiet pulley at the top and tension pulley at bottom. The cage is spring-loaded and rotates in its plane to absorb chain slack. It moves side to side under spokes, quieted by an arm that uses a pelagram linkage to keep cage aligned with chain. This arm connects to a pivot point on the bike frame, which allows it to adjust its position to stay evenly spaced from spokes of various sizes. Anatomy of real Delirious. It has three anatomy: short cage, medium cage, and long cage. Short cage, these are usually seen on road bikes with closed space gears. Medium cage, ideal for bikes with a moderate gear range, such as gravel or cyclocross setups. Long cage, typically used on mountain bikes. Delirial hanger. The delirial hanger is a small part that attaches the delirial to the bike frame. It serves as delirial's maintaining point and is designed to absorb impact in event of crash, helping to protect both delirial and frame. Springs and adjusting screws in real derailleurs. Springs are essential for derailleur's function, helping manage movement and tension. Return springs. This spring pulls the derailleur back when cable tension is realized, allowing chain to shift to smaller spokes. B-tension springs works with B-tension screw to adjust derailleur's height relative to cassette, ensuring proper chain engagement and smooth gear translation. Adjusting springs fine-tune derailleur's position. High climbing screw, low cement screw, B-tension screw. Jockey wheels located within the derailleur cage. Jockey wheels quiet chain and ensure smooth shifting. Quiet pulley, cable anchor, and barrel adjuster. Materials and build quality. Entry-level derailleurs, often made of steel for durability, but tend to be heavier. Premium derailleurs use advanced materials like carbon fiber, titanium, and high-grade aluminum. They often include features such as electronic shifting and clutch systems. Electronic derailleurs replace cables and springs with motors and electronic circuits. They receive signals from shifters to from precise, fast, and consistent shifts. Thank you for listening us.